Welcome to 11.6 today. To start with 11.6, we will be talking about your secant segments, which remember is when it intercepts the circle 2 times. An external secant segment, which is an outer part that we'll talk about a little later, and your tangent segment, which intersects your circle 1 time. Okay? At this point, I would like for you to go back in your notes and find that cheat sheet on surface area and volume, and I would like for you to fill this in. Go ahead and pause this recording right now, and I will go through, I'll fill it out, and then you can compare and see if you've got the same thing. So go ahead. All right, now that you are back here and you've got this all filled out, let's take a look at her. So looking at our surface area right here. The surface area of a prism is equal to the perimeter of the base times the height plus 2 times your base. The volume of a prism, remember, is equal to the area of that base times the height. Going down and looking at our cylinder, it is very similar for surface area, except for instead of writing our general perimeter formula, we just know perimeter of a circle or the base of your cylinder is 2 pi r. We multiply that by h, and we add it to 2 times the base, or 2 pi r squared. When we are looking at the volume of a cylinder, you should get volume is equal to pi r squared times your height. Okay, coming down into our pyramid, the surface area of a pyramid, remember, is equal to 1/2 times the perimeter of the base of that pyramid times the slant height L plus the area of the base. Your volume is then equal to 1/3 times the area of your base times the height. For your cone, your surface area is a little different. Its surface area is equal to pi times your radius times your slant height plus pi r squared. We'll fix that too a little bit. And the volume of this is going to be equal to 1/3 times pi times r to the second power times h. And last but not least, we've got our sphere. The surface area of a sphere is equal to 4 times pi r squared. And lastly, your volume is equal to 4/3 pi r to the third. And then zooming out here for you so you can see the whole thing completed, it should look something like that. At this point, I would like for you to, once again, pause the video, work through your warm-up, and when you are done, you can go ahead and press play again, and we will go through it. Okay, at this point, what you should have got here for number 1, if we zoom in here really quickly, number 1, you should get that x is equal to 4. Number 2, you should get x is equal to 48. And then number 3, remember, for number 3 problems like this, if you have 2 tangent lines that are coming from the same external point, they are congruent. So you need to set 3y plus 5 equal to 5y minus 1. Solve for y, and then substitute it in to get the length of BC. And your length of BC should be 14. I do expect you to know how to do this. This next part here, this shouldn't be anything new. The only difference is it's called a tangent segment because it is a segment of your tangent line and your endpoint ends on a circle. Remember, the difference between segment and line is a segment is just a part of a line. It stops. It's got a definitive start and a definitive end. Or a line or a ray goes on for forever. When looking at 2 tangent lines, okay, we notice that their vertex will be located on the outside of the circle. And just like before in your warm-up, AB is going to be congruent to CB, or they're also going to be equal to each other. And you'll need that equation right here to help you solve. So it might help if you just go through and we highlight this equation, AB is equal to CB. This next part here is a little new. It's asking what is our relationship between the 4 line segments AE, EB, CE, and ED. Okay, our relationship that we have here is if you notice, all of AB and CD, the big pieces, are chords, okay? We have a chord, AB, AB, and we have a chord, CD, okay? The relationship is that the parts of these chords are actually going to have the same product. So if we look, we've got CE, which is 2. And if we multiply that to the other piece, ED, it is actually going to be equal to the two pieces of the other chord, AE and EB. And if we substitute in what we know that 2 times 6 is equal to 4 times 3, or we can say 12 is equal to 12. And here is actually just reiterating what we said on the previous slide. When we have two segment types that are chords, we have a chord and a chord, the location of the vertex will always be on the inside of the circle. And the diagram, as you can see, has them crossing on the inside, and this is actually the exact same thing we just went over. So if we look, we'll just highlight our equation we're going to need from this so we can apply it later. So let's go ahead here and actually apply what we just learned. So we just found out that when you multiply the parts of those segments together, they are actually congruent. That does not mean that your chords are congruent, though, and we'll find out here in a second. So it says, find the value of x and the length of each chord. So we're going to take AE, which is 6, and we're going to multiply it by 5, which is EB. We're going to set that equal to 8, which is DE, times CE, or x. So we end up getting 30 is equal to 8x. Solving for x here, we're going to get that x is equal to 3.75. And that helps us solve the first part of our problem. What is x? So I'm just going to underline it because we're going to need it. Then it says find the length of each chord. Well, we know the length of AB is going to be 6 plus 5, or 11. We know that the length of CD is going to be 8 plus our new x, 3.75, or 11.75. This next piece you're going to have to pay attention. Remember, a secant line is a line that intercepts a circle at 2 or more points. A secant segment is just a portion of that line. Okay? So if we look, it says PM, NM, KM, and JM are all secant segments because they are on that secant line and they are just segments that go with it. An external secant segment, then, is the part of that secant line that is outside the circle. So if we look, NM and JM are actually your external secant segments because they're a part of those secant lines, MK and MP, but they are the parts that are outside of our circle. And we need to figure out what is the relationship between these segments that were formed. So before with our chords, we just multiplied them together and then they were congruent, whatever. The only difference is here, instead of multiplying the two pieces together, this first part we're going to look at is AE, the whole thing, times the external part, BE, is going to be equal to the whole line CE times our external part, DE. Or if we look, it'll be 20 times 6 is equal to 15 times 8. Or if we actually multiply those through, 20 times 6 is 120. 15 times 8 is 120. And here is our piece describing what we just did. We have two types of lines, or secant lines. The vertex is on the outside or the exterior of the circle. And if we look, it's the exact same equation that we're going to go ahead and highlight here, that our AC times BC, where AC is the whole thing, BC is our external part, is equal to EC times DC, where EC is the whole line, DC is our external part. And then once again, we're going to work through an example here together. It says find the value of x and the length of each secant segment. So if we look here, it actually is a little bit different because our line, when we're solving for x here, the whole line GE is actually going to be, let's undo that real quick. The whole line GE isn't just x, and it's not 8 times x or anything like that, is actually going to be 8 plus x. Add the two pieces together. And then that's times the outside part, which is 8, and that's equal to the whole thing, 9 plus 7, or 16, times 7. And when we go through this, we're going to distribute this 8 in, and we get 64 plus 8x is equal to 112. And then going ahead and solving for our x here, we get 8x is equal to 48, or x is equal to 6, and we're going to underline it because that's not the final part. We then need to figure out what is ED and what is EG. Our line ED is equal to 7 plus 9, or 16. Our line EG, that's a 6, my bad. Our line EG, is equal to 14. So once again, notice that when you multiply them, they do have to be congruent, but when you solve for the actual segment, they do not have to be congruent segments. So on this next one, we're once again looking at relationship between segments. Notice we got a tangent line, or what's supposed to be a tangent line, and a secant line. Once again, your secant line, that formula is actually not going to change. It is going to be the whole thing AC times its external piece BC, but the difference is our tangent line, we used to say our tangent lines were equal to each other. Well, in this case, our tangent line is going to be itself, DC, squared. So if we substitute this in, we'll have AC, which is 8, times BC, which is 2, has to be equal to DC, 4 squared, or 16 is equal to 16. And then looking at our rule here, our segment types is we have a tangent line and a secant line. Our vertex is still on the outside. And this time our equation, which we're going to highlight again, is going to be equal to your tangent line squared. And you'll notice that your secant line, the formula for your secant line will never ever change. So on our next example here, we need to solve for x. That's all we want to do, solve for x. So we're going to take our whole secant line ML, which is 20, and we're going to multiply it by the outside, which is 5. Sorry, that's a little sloppy. Let me redo that. The outside, which is 5, and that's going to be equal to our tangent line x squared. Well, 20 times 5 is 100. That's equal to x squared. To get x by itself, to undo the squared, you got to take the square root, and we get that x is equal to 10. And last but not least, I would like you to actually do this one on your own. So go ahead and pause the video. I will let you know you are going to need your notes from the beginning of this section to help you out. So pause it, work on it, come back, and I'll work through it. Okay, welcome back. If you notice, our diameter here is going to bisect this chord. So this is going to be actually 9 inches and 9 inches. If you remember back in our rules, to find the diameter, we have a chord and a chord here. So we're going to just set this little piece to x, and we're going to set it up as 9 times 9 is equal to 8 times x, or 81 is equal to 8x. Go ahead and solve for x. We're going to divide both sides by 8, and we're going to get that x is equal to 10.125. If our x is equal to 10.125, that actually is going to tell us that our diameter then is just 8 plus x, or we can say it is 18.125. Thank you for going through this whole video and actually paying attention. Those of you that didn't obviously won't know the homework, and I am not going to tell you what it is unless if you weren't paying attention. It is on page 795. You have problems 1 through 11, 15, 22, 45, and 46. Thank you and have a good day.